All right. In this section, we're going to be comparing two means. Now, if you remember right, there were two ways to do that. If we know the population standard deviations, or if we don't. If we know the population standard deviations, we can use a z. If we don't, then we use a t, which means it'll be dependent on n in each case. So let's start here. Two samples are independent. If the same values from one population are not related to or somehow naturally paired or matched with the sample values from the other population. Actually, part 3 is going to be if they are dependent, then what do we do? And we'll talk more about that in a bit. So we're going to do a hypothesis test of a claim of two independent population means. And what we were with the standard deviations, unknown, which means t-test. And we are going to assume that the two standard deviations, are not the same. That's a 1, sigma sub 2. And so what we say is that these are not pooled. If they are pooled, we will have an option with our calculators as well. There's a few requirements. The values, once again, of sigma sub 1 and sigma sub 2 are unknown. And we don't assume that they're equal. That's what I just wrote up here. The two samples are independent. Both samples are simple random samples, and we are going to assume that n sub 1 and n sub 2 are both bigger than or equal to 30. Or we already know that they're a normal distribution. In that case, it doesn't matter what n is. And I was here going to write out the formula for you and everything, but we're really not going to use it. So the main thing we need to know is that this is going to be a two-sample t-test with degrees of freedom of n minus 1, or n sub 2 minus 1. And the idea here is whichever the smaller of the two. There's actually another way to calculate that out, and you'll see the calculator will calculate it out in a different way. We're not going to worry about it. We're just going to use this. It'll work out just fine. So here's our example. Assume the two samples are independent, simple random samples selected from normally distributed populations. So now we don't care what n is, even though it's, in this case, n is definitely bigger than 30 in both. We are also not going to assume that the population standard deviations are the same. So we're not going to be pooling. The table gives the results of the words spoken in a day by men and women. You know, the old stereotype that women speak more than men and this, that, and the other. So we'll see if that's true or not, based on this made-up data, which I don't think is even real data. I'm not sure how you would even measure that. Use a 0.01 significance level to test the claim that the mean number of words spoken in a day by men is less than that for women. So let's write what we mean by that. So our null hypothesis, we're going to assume that the means are the same. And this is typical of a null hypothesis. We assume that we don't know. Let's make it all equal for now. And the men is the sub 1 and the women are the sub 2. You can make that what you will. And here is our claim. So, since we are going to be using this here, and because it's less than, that's going to be a left tail. And they gave us a significance level of 0.01. And we can use inverse norm with that. Inverse norm of 0.01. And that gives us a negative 2.33, we'll call it. And we have all this good data here. And what we're going to do is we are going to use, once again, a two-sample t-test. So I'm going to go back to stat, to the tests, and this is a two-sample t-test. You can see here. And we don't have raw data that's put into list 1 and list 2, so I'm going to go over to stats. And here's my X bar. Let me quickly, before I start putting that in, show you on a Casio, because I'm kind of neglecting that. If you do have a Casio, you have to go into menu 2, and all of your tests are here, and all of your confidence intervals are here. So you just hit there, and you'll figure out which one you need. So this is a two-sample t-test. And if I wanted an interval, I could do a two-proportion z interval if I needed to. So all of your tests are right there. So you're welcome to do that. But I'm going to stick with the TI because most people have a TI. And I'm going to enter the data in here. So we have 15668.5. Standard deviation is 8632.5. N sub 1 is 186. X sub 2 is 16215. S sub 2 is 7301.2. And here we have 210. And going along with what we have, we're there. And is it pooled? No. We made a kind of a big deal about that. Up here, we are definitely not pooling. And calculate. So this very nicely gives us our test statistic. And more importantly, our p-value. 0.25 is what that looks like to me. And we, of course, would compare that to, this is significantly larger than our alpha, which is 0.01. So it's very nice this technology does all this work for us, because the formula that we would have to use is quite horrifying. But workable. And our conclusion, because our p-value is larger than our alpha, is that we are going to fail to reject the null hypothesis. So there is not sufficient evidence to support the claim that women talk more than men. So based on this data, it's not true. Women don't talk more than men. Just the way it goes. Let me, in the picture, also kind of point out where we are. So if I'm here, this value right here is the negative 0.68. And my p-value is all of this is 0.25, which we can clearly see that our critical value is not in the critical zone there. All right, confidence interval. So we're looking for the same thing we were looking for before. And our confidence interval is going to be based on the assumption that mu sub 1 minus mu sub 2, which is going to give us and this is where well, I can define E, but again, the calculator is going to do all this for us. And if need be, this would be Z. If the standard population standard deviations were known, which here we're assuming they're not. And once again, the degrees of freedom are going to be the n sub 1 minus 1 or n sub 2 minus 1. It's going to be the smaller of the two. But again, our calculator is going to do all of this work for us. So for this one, we're going to do the same thing, except now we're going to do a 2 sample t interval. 2 sample t interval, there it is. 2 sample t interval. And it already has all the data in there for me, which is nice. The sea level, they did not mention. We will use the same one that we had before, which was 0.99. And let me write that out. So we're going to assume that alpha is 0.01, which means our sea level is 0.99, which you can see here. Still not pooled. And calculate. And this is very nicely going to give us negative 2641 to 1548.3. And again, we were going from a negative to a positive. So 0 is, and when I say probably, I mean that in a statistics point of view, is with all probability is within the confidence interval. So once again, we would come to the same conclusion as here. We would fail to reject the null hypothesis, since it's all the same data. All right, so now I'm actually going to skip this part. This is if with sigma sub 1 and sigma sub 2 are known. This means we're going to use a 2, I forget what they called it, a 2 sample z-test. And you don't need to see, I don't even have an example for that, so we'll move on. Right now, we're going to talk about if sigma sub 1 and sigma sub 2 are unknown, so we're still t-test. But now we're going to assume that the two population standard deviations are equal, which means we're going to pool it. And once again, sigma sub 1 and sigma sub 2 are unknown, and they are equal, so we're pooling, once again. Samples are independent. They're both random, and again, the sample size of both have to be bigger than 30 if we don't know if they're normally distributed or if we know that they are not normally distributed. If they're bigger than 30, then we can proceed as though they are. If we know that they're normally distributed, then n doesn't matter as far as running it. Again, I'm not going to get into the formulas that are involved here. The degrees of freedom, though, are a little different. And again, I'm not going to get too in depth with that, but I do want to come back to our problem here. So now we're going to assume that the population standard deviations are equal, which means we're going to pool. That's what that statement says. They give us an alpha of 0.01. So once again, I'm going to go down to, let's write out our null hypothesis. So null hypothesis, mu sub 1 is less than mu sub 2, is equal to, of course. Our alternative hypothesis is that mu sub 1 is less than mu sub 2. And we'll write this out here. once again, pretty much everything's going to be the same, but now we're pooling. And if I look back on the previous one, I've already done the negative 2.33. So now when I run the two-sample t-test, everything's going to be the same except we are pooling, meaning we are assuming that the two standard deviations are equal. And this is going to give us our test statistic. Of t equals negative 0.68. And our p-value is a little bit different, slightly. Actually, it's about the same. So, as the previous one. So not a lot of difference between those two, but still our t is way out here. In either way, we still fail to reject the null hypothesis. And it's the same statement that we had from the previous. There is not sufficient evidence to support the claim that women talk more than men.